Hello again, welcome back. Review number 3, general review number 3, lecture number 66. Again, I'm just randomly put some problems up and we'll see if we can do them together. Okay, so let's see the first one. 60 calories of heat are added to 10 grams of element X, whose specific heat capacity is 0.25 calories per gram per degree Celsius. By how much does the temperature rise? So we're looking for delta T. Whenever I see specific heat capacity, I think of this equation, right? Q equals MC delta T, right? I call it the wrapper equation, like MC Hammer, okay? Remember, you should like the math problems for the simple fact that on this level, every problem I give you, if you find the equation, you have everything in that equation except for the one thing we're looking for. So if we look at this equation, Q represents the heat, which I'm telling you is 60 calories. M is the mass, 10 grams. C is the specific heat capacity, is 0.25. And so we have to find delta T. So we know Q, we know M, we know C. We need to find delta T. Simple, plug in. So if we solve this for delta T is just Q divided by MC. 60 calories, 10 grams, I can't fit it in 0.25 calories per gram per degree C. All right, you can see this goes down here, okay? So we have to divide that, okay? So 240. So I think the answer, if I do this in my head, 24 degrees C. Now very quickly, let me just tell you what I did. 0.25 is 1/4. If I bring the 4 up, 4 times 60 is 240. Then I divide by 10, I get 24. So I save time by not using a calculator, but you have a calculator. Try to use it wisely. Okay, so my answer is the temperature increases 24 degrees Celsius. Fantastic. All right, and 8 mu A, what is that? Microamp, we'll go over that in a second, device has a power rating of 40 nanowatts. So again, we need to find, I'm giving you equations and we have to find the right equation. I give you everything in that equation, everything except one thing. Then you got to plug in and hopefully get the right answer that we agree on. All right. So I'm giving you I'll write it here. I is 8 microamps. Remember, that's 8 times 10 to the minus 6 amps, right? Micro. The power, P, is what? 40 NW is 40 NW is 40 times 10 to the minus 9 watts. Nano. Okay? Now we have P equals IV. If I know I and I know P, we can find V. Isn't this amazing? Okay, so V looks like P divided by I, which is 40 times 10 to the minus 9 watts divided by 8 times 10 to the minus 6 amps. So 8 into 40, 5 times 10 to the minus 9, 10 to the minus 9 divided by 10 to the minus 6 is minus 9 minus a minus 6 is minus 9 plus 6 is minus 3. And the answer is in volts. And so that's the same as 5 millivolts. Right? 10 to the minus 3 is 5 millivolts. Good? And I can erase over here. So we found V, we want to find R. We can use Ohm's law, V equals IR. So R is V over I. What do we say V was? 5 times 10 to the minus 3 volts divided by I, which was 8 times 10 to the minus 6 amps. And so R, 5 over 8, well, all right, 8 into 50 is what? It's about 6, right? Because that's 48 with a remainder of 20. So it's about 0.62. Again, use your calculator. 10 to the minus 3 divided by 10 to the minus 6 is 10 to the plus 3 ohms. And so, if I wanted, we could write this as 0.62 kilo ohms, right? Kilo is 10 to the third. So, that's a good answer. Okie doke. Great. Let's go on. Take this out. So all these math problems really are just plugging in. That's why everybody seems to like the physics, because once you know what equation to use, you're just plugging in and using your calculator. Chemistry, maybe a little more thinking, not so obvious. All right, when 20 identical resistors are connected in parallel. All right, so remember, parallel is 1 over R plus 1 over R plus 1 over R. I have 20 of these. So what I have 20 divided by R is equal to, remember that has to be 1 over R equivalent. So I have 20 divided by R has to equal 1 over, what did I say R equivalent was? 5. Okay, so how do we solve for R? Come on, you can just cross multiply. R equals 100 ohms. Right? So it's clear that 20 divided by 100 is the same as 1 over 5. Okay, so that's in parallel. What happens if they're in series? Now in series, what do we have? We have R plus R plus R, right? We just add them. So we get 20R has to equal R equivalent. So 20R is equal to 5 ohms. R is equal to 5 over 20 ohms. And so 5 over 20, what's that, 1/4? It's 0.25 ohms. So when they're in series, it's 0.25 ohms. Okay? And when they're in parallel, we said it was 100 ohms. Great. Once again, pretty easy. All right, let's look at this nuclear balancing equation. Okie doke. Remember, the bottom is the charge, the top is the number of nucleons, the number on top has to be the same on each side, and the number on bottom has to equal the same on each side. So let's do the top first. Here, 3 times 4 is 12, plus 140 is 152. Okay? Here we have 0 times 6 is 0, so the top here must be 152. Wow, this is really tough, isn't it? All right, the bottom, 3 times 2 is 6, plus 80 is 86, so we need 86 on the bottom. What number minus 6, because 6 times a minus was minus 6, what number minus 6 is 86? That should be 92. So 92 minus 6 is 86, and 0 plus 152 is 152. Okie doke, let's get rid of this crap. And let's do the last one here. Okie doke. On the top, 8 times 0 is 0, so we get 52. The top here, we have 20 plus what is going to be 52. Right? So it looks like it's got to be 32. Correct? 5 times 4 is 20. 20 plus 32. Fantastic. We're so smart. 8 times 1 is 8. Plus 22 is what? 30. 10 plus what is 30? Well, it looks like 20. And there's our answer right there. Okay, so nuclear balancing is pretty easy. Okay, so again, randomly, let me just do Let's try to name this little beast. Okay? There's a triple bond, so it's an alkyne. Okay, CnH2n minus 2. The longest chain is 6, 7, 8, 9. So it definitely looks like a no 9. It's good. If I count from here, it's carbon 6, carbon 7. The triple bond would be on carbon 7. That's high. If I count this way, 1, 2, the triple bond is on carbon 2. So this is simply a 2, no 9. Okay? Very simple. I'll just randomly do this. Okay. Let's see if I filled everything out. All right, looks like I filled everything out. Oh, I'll put an H here, sorry. Okay, looks good. So now let's count, try the longest chain. I see all single bonds. Okay, so it's an alkane, paraffin, CnH2n plus 2. Let's count. 4, 5, 6, 4, 5, 6, 4, 5, 6, 7, 8. 4, 5, 6, 7, 8. 4, 5, 6, 7, 8. 4, 5, 6, 7. 8, 9, 10. 4, 5, 6, 7, 10. 1, 2, 3, 4, 7. I think that's the longest chain. It's good. So I think it's a decane. I'll write that here. If I did it right. It's good. And what else do we have? Well, we've got a methyl, a methyl, a methyl. I don't know. What is this beast? Can we see what this beast is? There's 1, 2, 3, 4. So it's MEPB, right? It's a butyl. Butyl comes before methyls. These are methyls. Methyl. Methyl. So these are all additions to the chain. If I count this way, 4, 5, 6, I think I need to count this way. 3, 4, this is carbon 5, right? So I have, looks like a 5 butyl. You do this yourself and make sure I'm not making a mistake. 5 butyl, now we said this was carbon 4. So 5, so we have 4 methyl, 5, this is carbon 6. 4, 6, 6, trimethyl. All right, you make sure I'm correct on this one. But it looks like a 5 butyl, 4, 6, 6 trimethyl decane. Okay, I know we've had a couple of reviews on organic chemistry already. Let's just stick with organic for another second. Let's just write a couple things. Okay, let's look real quick. C2H2, N is 2, 2N minus 2 is this. So Me, 2 carbons is F. So this is ethyne, triple bond in there. N, 2N, it's an ene, alkene. 7 is hep, so this should be heptene. 8, oct, 2N minus 2, because 2N is 16, minus 2 is 14, so it's octine. And then finally C10H2N plus 2, decane, okay? All right, this is just a random bunch of things to review. All right, we'll do another review, see what we can do. Be safe, study hard, take care of yourself, and peace. Peace out, everyone. Bye.